Welcome to the Scaling Tech Podcast, the podcast for software engineering leaders. I'm Arin, your host, and I'm excited to bring you a conversation today about a topic all software teams struggle with: technical debt. We all create it, we all have to clean it up, and we all have to make trade-offs about when and how to deal with it. Lou Franco is my guest today, and he's an expert software engineering leader who will share with us insights about how software teams can deal with tech debt. Before we start the interview, though, how about taking a second to like this episode and follow us on the podcast platform of your choice? Since this is a topic that all teams struggle with regularly, this would also be the perfect episode of the Scaling Tech Podcast to share with your colleagues. I'm sure that Lou's advice will help them, and it also helps us to keep bringing you insightful interviews like this one. So let's get to my interview with Lou Franco and tackle some tech debt.
Welcome to the Scaling Tech Podcast, where we help you manage your growing engineering team. Through expert interviews, we help you navigate the challenges of leading, hiring, growing, and nurturing your tech team to deliver the value your customers demand. Brought to you by AgilityFeet.com, experts in staffing engineering teams in Latin America for clients globally.
Lou Franco is a software product development advisor and independent engineer who is currently writing a book on tech debt. Lou has been on the leadership team of 3 startups with successful exits and also was a principal engineer at Trello when it was acquired by Atlassian. He has 30 years of experience delivering applications for financial institutions, enterprise companies, and startups. You can learn more about his upcoming book on tech debt by visiting loufranco.com. And today we're going to talk specifically about team practices for addressing technical debt. Welcome to the Scaling Tech Podcast, Lou.
Thanks. Nice to be here.
It's a pleasure to have you here. Appreciate it. I want to start with asking you to address the whole notion of tech debt at kind of like a high level, because to me, at least, it's sort of like the debate of feature versus bug that developers often get into. Why does tech debt matter? And why do teams treat it differently than other features to be developed?
That's a really good question. And honestly, when in my first drafts of the book, I tried to not address this because I was hoping that we would come to it as engineers with a common understanding. And what I found out very quickly is that was not the case. And so so I had to take kind of a stand on it. And this is where I come to it. So I think that tech debt's on a continuum, just like the feature and bug. Like there's obvious features and obvious bugs, and there's a murky middle somewhere in between. Tech debt's going to be like that to some degree. I think the kinds of things that make it more like tech debt is the more that the benefit of paying it is to developers themselves working on the code, that the more it's about developer productivity, then it's more likely tech debt. The less visible it is to customers and stakeholders, the more it's like tech debt. So, for example, things like security problems or performance problems, I would not put those in tech debt immediately because they are something that can be understood by your stakeholders. So I want to treat things more like tech debt or do something more about it if it's actually affecting me right now. So if it's a developer productivity in what I'm trying to do, rather than just theoretically a developer productivity issue. It's in the code, it's bad, but I never change it, so it's fine. So those are the kinds of the big things I look for to characterize something as tech debt. And then you asked, why should it be treated differently? And it's kind of because of those reasons. So because of those things, product managers won't be the best people to specify what to do about it. The engineers themselves on the team are the best people to write benefit statements or acceptability statements or anything about what it is they're trying to do and how they're trying to do it. And actually, the product manager probably doesn't care that much about it. So that's why I would treat it differently. So because of the way I've defined it, it's just going to be the engineers that are going to be doing the most work with it.
Yeah, that makes sense. Yeah, so if it affects the productivity of the engineer or the way that they work, then there's a good chance that it's technical debt. But I guess just to kind of clarify, it doesn't necessarily mean that tech debt comes from the engineer or the actions of the engineer. I mean, it could be introduced by a rush on a business feature, or
Or
could come from a number of
oh
sources, right?
yeah. In fact, the thing I think it mostly comes from is just the world changing around you. So you, I think we a lot of times if you look up the, let's say, dictionary definition of tech debt, it's going to say something like it was a shortcut taken by a developer and now it's come due or something like that. Thinking about it more like mortgage debt or credit card debt. And actually, I kind of reject most of the financial debt metaphor because it makes us think that way. Whereas I think of it more as just it's resistance that's slowing you down, and you care about it because you're trying to go that way. And so I wouldn't characterize it as something that comes from a shortcut. I think of it more like I said, the world changing. For example, I worked my first job. We wrote desktop applications for DOS. Okay. So, and they were fine. We didn't have shortcuts. The code was great. It worked exactly as it should. And then Windows came out, and we were kind of okay with that. We could deal with it. Just have to change the rendering part of the program. Most of the rest was okay. And then the web was invented. And then basically the entire code base was now tech debt. It's not
Right.
because we took shortcuts. We didn't know this existed, but just things changed. And that's happening.
Mhm.
Mobile, AI, these things are just happening. It's turning entire parts of code bases into what I would characterize as tech debt, in the sense that you can't move forward in the way you want to with the
Yeah.
code base you have.
Interesting. Yeah. No, that makes a lot of sense to me, and I guess fits within something I know I've said before, and I've heard others as well, that software kind of naturally decays a bit over time. Even if you're not touching it, or maybe because you're not touching it,
Right.
as the world changes around.
The world changes around us. Dependencies get updated. OSs get updated. And if you're not keeping up, then eventually your code's not going to work anymore.
Yeah, that makes sense. So tell us a little bit more about your journey as a software engineering leader and how you came to the decision to write a book about technical debt.
So I've been a professional software engineer, engineering manager, software engineering executive, and so forth for about 30 something years. Most of that were in 4 jobs. And they're very similar to each other. And that's what a lot of my perspective comes from, this common background. So I was at 4 startups where I was, within the first, at one place, a founding engineer, at another, usually within the first 10 to 15 employees. And 3 of those ended up being acquired. They all had successful exits, but I ended up multiple times at just some larger company, public company, or just some larger company, where I was at the startup. I might have been like at the CTO or high up in the engineering org chart, but then in the larger company, I'm a middle manager, or in the case of Trello and Atlassian, I was a principal engineer on the Trello iOS team. So I had to learn how to operate in those startups and then also giant public companies. So that's where I get, and all of those companies were B2B. One was financial, one was developer tools, and then Trello is like work productivity. So that's the general background I have. A lot of my perspective comes from being in B2B, product software, really small companies, and then giant companies.
And you went straight from the startups right into those giant companies. You sort of skipped a size in between, it sounds like, which must have been a shock.
Trello got to a couple of hundred people, I think, before it got acquired. But yeah, the third startup I was in was, we had, I don't remember, less than 20 people, and then we were in a public company.
Yeah, there must be quite a culture shock. And I guess, ask this kind of question 2 ways. One is going from that large abrupt change from a 20-person startup to a public company. I imagine they, in each environment, you're thinking about tech debt differently. And, I guess the other way to, what would you say that successful larger companies like Atlassian, what do they know about technical debt that other teams struggle with?
Well, Atlassian is potentially an outlier because they service the developer market, and so they're very attuned to the developer as their customer. And if you go on their site, you're going to find all kinds of thinking about tech debt. You can use their products to manage tech debt. So that being said, the thing at Atlassian that helped the most is the model which I think is, popularized by Spotify, of teams being independent from each other in their processes. Now, there are, obviously a lot of things that are the same across teams, but they were independently, we could independently operate. So on my team, I was on the Trello iOS team. We had 10 engineers when I left. Maybe I can be considered of the larger mobile team, which is about double that size. These two teams had a lot of similar processes. We had shared managers, so that made sense. But we didn't have to in any way try to coordinate our way of thinking about tech debt with any of the other teams. We would just treat those as lessons learned, try to get those things adopted based on their merits to other teams, and maybe there would be some kind of way that was more the Trello way. But there really wasn't a Trello way or an Atlassian way. There was a mobile Trello way that we followed, and because we were able to be independent, I think, and that's the main thing that the Atlassian management did, it just let us find something that worked for us, which I think it did work very well for us.
Yeah, that's an interesting observation. So, I mean, this is an area where, the way executive leadership structures kind of the company organization can make a big difference in how to address technical debt. Because if teams are kind of self-supporting, long-lived, working in an independent part of the application and don't have a ton of external dependencies, that can help with, the architecture in general and with how they manage technical debt. And, so that makes a lot of sense to me. And no, there's a lot of aspects of technical debt. I know that, your book is going to address like things that individual developers can do around technical debt. In our conversation today, I want to focus more on the section about team practices. And so I think, a lot of our listeners are engineering leaders. What are the most important practices that they can instill in their team about technical debt?
So I'm going to talk about some enabling practices, just things that if you put into place, it makes the other things easier.
Right.
So one, every team has this, I'm sure, but some kind of style guide. So you have your style guide. You have, do I use tabs? Do I use spaces? How do I use curly braces? That's great. Hopefully you use automatic formatting to deal with that. What you also want in there is something about your that addresses some of your tech debt ideology. What's your for example, if code coverage is something that you care about, that you would have some statement about it there. If you're measuring complexity of individual functions, that you might have some statement about that. That if you have a target architecture. So like on the Trello iOS team, the app was started in 2011 in Objective-C, in UI Kit, all the things that were the totally correct choice in 2011. And then 2014, Swift comes out. In a few years later, there's Swift UI. Now the way to make an app is totally different. We had a target of what we would want most of the code to be. We wanted it to be in Swift, and we wanted all new code to be in Swift. But what we also said was it was acceptable that if you're working on a piece of code that was in Objective-C and you were going to be doing, some amount of work on it, not just a simple bug fix one-liner, but some amount of work, it was appropriate to first convert that code to Swift and then to do the work that you were intending to do. That it's not that hard. It's not like it added much to the project. But because we did that and it was in our style guide, it was never a question at review time. So that's what you're trying to do. This style guide is to answer all the questions to make code reviews go faster, and everyone understands what's acceptable and what's not. And I think that's a really important enabling team practice. Another one, and this more involves management, but I think hopefully and we did this on our team in Atlassian because our manager had gotten it to be done. I don't know. I actually don't know if it was a practice throughout Atlassian, but we had segregated PM-led resource allocation and engineering-led resource allocation. So I'm just going to pick a random number just because it's arbitrary. You pick whatever you want. But let's say it was 70-30, PM-led versus engineering-led. And what I'm talking about here is not all of your time, because obviously there's other things that you do during the week, but the time that you're doing the coding, the pull request reviewing, the working on the code base was split, let's say, in this arbitrary case 70-30, that would mean that 70% of the time the team somehow is working on PM-led feature development or whatever it is that they want to do, bug fixes that the PM wants to do, and 30% it would be the engineering led. And within engineering led time was tech debt. So tech debt is just one of the things that you could do with engineering led time. There might be other things like setting up a staging environment or updating dependencies or all the kinds of things that engineers have to do to keep a code base running. A really important thing about the engineering led time is that within that allocation, the engineers are in charge of how to allocate it. So they have to stay within that 30%, let's say, but they don't have to get buy-in from anyone outside of the engineering manager and the team itself. And so they can decide which tech debt to pay off if they want to, or perhaps they want to put it towards tooling or building more environments or whatever it is that they might want to do. They can do that autonomously without having to get buy-in. So those are my enabling processes.
Yeah, that's great. And so within the engineering-led time, the engineering team basically has total control over kind of what they're working on there, how they work on it. Are there in the allocation of or like how much engineering-led time are there areas of contention between product-led and engineering-led time that leaders need to think about how they navigate that contention with their teams?
This is something, obviously, the product org and the engineering org, the PM, EM, or whoever's going to do it needs to negotiate that. I think there are some guidelines. I go into that in the leadership part of my book. There's going to be an appropriate amount of time depending on where you are in the customer adoption lifecycle. So this is something that comes from Jeffrey Moore. Crossing the Chasm is the famous book about it, but there are other books about it. But generally, a product goes through a customer acquisition life cycle, customer adoption life cycle. There's the early part where you're learning about your market. Then you find product market fit. Then you might have huge growth, but then there's a leveling off and a maintenance phase, and maybe even like a phase where you're you're not growing or shrinking and you're a cash cow and trying to get your maintenance. Maybe you might offload it or offshore it or whatever at the end of that cycle. Where you are in that cycle is giving an indication of how much of the split you might be. When you're at the very beginning, there's probably not going to be much tech debt paying. You're going to have engineering activities, of course, but it would probably be the case that a large majority of the time would be PM led.
One thing I was thinking about as you were saying that is, I think earlier I kind of phrased a question in the way of, what should engineering leaders do to instill in their teams about technical debt? And really, I was kind of framing that from a pretty top-down approach. But a lot of what you've been saying, I'm picking up on. You're saying very much how the engineering team as a group too. And so, I guess maybe there's a distinction here that the balance of product-led versus engineering time is going to be dictated somewhat by the stage of the product life cycle that we're in. That's something that may be negotiated at kind of like a leadership level, an engineering leader level.
In a big company, it might be different for each product. And it also might be different for different teams on the product. So like there might be part of the product that is very much in that learning phase. It's about new growth. And there might be parts of your product you have to maintain them. They're important. A large user base is using it, but what might be appropriate there is optimization. You might want future team reduction. In that case, you might need to do a lot of tech debt paying off so that maybe you can bring in a more junior team to do that maintenance. So that might be, again, it's going to depend on the business needs of the code itself. Somewhat is one of the things that affects that. Another thing that affects is like how much tech debt is in the code base. Is it a really big problem that's really impeding you? Well, then you might have to have a larger allocation if that's the case, no matter where you are. But there's going to be various things that affect that allocation. You're going to find it out through probably trial and error experience.
Yeah. So how do you schedule for that tech debt time and the product led versus engineering led? Do you do it within a sprint planning process? Do you
Right.
allocate a portion of time or dedicate individuals to it or dedicate a
Right.
whole sprint to it? Like, what do you
Yeah.
recommend?
So, okay, so there's a couple of different things that to talk about there. The one thing I should say is I think of this entire tech debt management part as being very analogous to what the PM is doing before they put things into your real backlog. So, but
Okay.
it's an activity that's happening mainly before the real backlog.
Yeah.
So I recommend doing it in separate software. It could be the same software, just a different space. Like you can use Jira for this if you want to, or you could just use a spreadsheet or a Trello board. It doesn't really matter. But your key, whatever a PM uses is probably similar, unless they're using a very product board or something like that. But something like that. You have a lot of ideas. You're not going to do anything with them yet. So that's happening kind of before the sprint. But let's talk about what happens at the sprint. So you've graduated some things, like you're going to do them. Yes, I do think they end up in the same place, whatever you do, sprint plan, whatever you normally do. But what I recommend, and again, you can do this however you want, but if the goal of what I'm recommending is so that you could know that you're meeting the budget. So like if you have a budgeted time, it's going to be very hard to know your actual numbers if what you do is just let random tech debt stories come in through the sprint planning meeting. So what I think you should do, and this is what we did on in Trello, is for a period of time, single developers were either allocated to be doing PM led stories or engineering led stories. So for example, in this example where we split it 70-30 and I had a team of 10, 7 of the engineers would be doing the PM led features and 3 of them would be doing the engineering led stories. And then now you can, over that quarter, let's say, or over like several sprints, what the actual split was. And yeah, people are going to do things back and small things off of that, but it'll be fine. Like you're mostly just trying to match it over the course over time. There are going to be times a quarter might come where like the PM actually is in a planning mode and they don't actually have a lot of things to work on. You might temporarily increase your engineering led time, but then you're going to make up for it in the next quarter when you're going to temporarily reduce it. You're trying to match this allocation over time. And the reason I suggest allocating engineers wholly for a period of time is purely just for accounting purposes. But I also think that if you do that, you get into a mindset where you can take on larger things because you're going to be doing it. You know how much time you have. So for example, one of the things I used to do when I was going to be put on this to begin with, and I was going to be working on a large piece of tech debt, one of the things I would do first off is put in observability right away, immediately, so that I could tell that whatever I was doing was having whatever effect I wanted. So if, for example, in one of the examples that I share in the book, there was a huge piece of code in this in our sync engine that I wasn't sure. I knew it was a tech debt. It was all in Objective-C. I knew there were problems with it, but I wasn't sure if customers were experiencing those problems. And so I first thing I did was put in way more observability than we had at the time on what was exactly happening. And even though we had, I'm going to say 99% success rate, we wanted 5 nines. That was our goal. So now I knew what the number was, and I knew that whatever I was doing was affecting that number because I could see it. So you can think that way if you're going to be on the project for a longer period of time, and that you can do it for a longer period of time.
That makes a lot of sense. I like it. And I like that idea of dedicating, a certain number of specific engineers to it for a period of time. It's similar also to how sometimes people think about how do you manage like new feature development versus bug development, and kind of back to that analogy again of, people rotating through doing these sort of production support tickets within a sprint versus those who are working on new features, but having a rotation in that so that everybody's getting, that full experience.
And it helps you stay in a mindset. You get more productive at it. If you don't like a certain type of engineering, there's an end.
Right.
It's not going to be forever. So that works out. That works out pretty well too.
Yeah, absolutely. I want to take a moment to tell you about our sponsor, WebRTC Ventures. At WebRTC Ventures, our teams are experts in building live video into your web or mobile applications. We've literally built hundreds of them. We have over a decade of experience using both open source and commercial media servers in a wide range of industries, including telehealth, edtech, broadcasting, and more. We also publish a lot of helpful tips and industry interviews on our website and our YouTube channel. So be sure to check out webrtc.ventures and we can help you build, scale, and deploy your video solution. And so in terms of tracking that tech debt budget, you're basically tracking it based on, team numbers and sort of an accounting, tracking in that way. You also mentioned putting those kind of pre-sprint, putting those in a separate backlog or, separate way of tracking that. Is there anything else kind of in the process of doing it that you would track around technical debt?
So one of the things, the flip side to autonomy. So like I want leadership and the rest of the company to trust that the engineers will do the right things. But there's a flip side to it. It's accountability flip side. So I do think that it's appropriate to ask the team to provide some sort of observability into what it is that they're doing. Sometimes, like for example, in the example I gave with the sync errors, it's something that affects customers and it's very easy for them to understand. But sometimes it's going to be a pure internal thing, but it's still appropriate to show a dashboard. We had a colleague on my team. We were sure, well, our build times in iOS, they were very bad. Our build times in continuous integration, even on our machines, and it was clearly a drag on our productivity. One of my colleagues built a script. Every time we built, it just threw the number into an analytics database, built a dashboard that showed how much time we were sitting staring at a computer compiling. And we were able to show that the things that we're going to do to fix it, just normal build, engineering type stuff. We could see what it was doing to that number. So that was an internal number, but there was still visibility. Our engineering manager could totally understand it. And all the way up the engineering org chart could understand it. And then we would have a real, they would know that we were using our budget well. I think it's appropriate. Yes, you get to choose. And yes, you are going to be doing the prioritization, but it is appropriate to ask you to have some transparency to what's going on. I think it's also appropriate to ask them to have some kind of rational process for picking. Like I don't think it should just be, we can do whatever we want. Like, so we're going to do whatever. No, you should have a process. I outline that process in the book. But essentially, if you know anything about product management processes, I'm talking to the audience. If you're aware of the like a technique like RICE, where it's like where a product manager might score a feature based on its reach and its impact and how certain they are of it and so forth. I also identify some dimensions of tech debt that I think are worth scoring so that you can use those scores as a way to have a discussion about the tech debt that isn't just opinions and gut feel. I'm not suggesting, and I don't think product managers do this, those numbers aren't a formula that means like, oh, if the RICE score is this, then you definitely do it or whatever. I'm suggesting the scores are going to prime you to thinking about tech debt in a certain way. And then I think based on those scores, different combinations of the extremes of those scores are actually going to point to different ways of dealing with that tech debt. So scoring ends up categorizing the tech debt in different ways, and then those categories kind of give you a direction to go in.
And are those I know you talk about like stay versus pay forces.
Yeah.
Is that part of that
Yeah.
story?
So I should talk about, so the question, the underlying question is, should you do anything? You have identified this piece of tech, should you do anything? And then if so, what should you do? So what I've started with is this concept of, in the end, why do we do anything? It's cost benefit analysis, right? Like that, like that. So I'm starting with a concept that comes from Bob Mesta. He's a product thinker. You can find him online, but he's famous for coming up with the jobs to be done methodology of product design. And one of the things he talks about is this concept of the 4 forces for making progress. And those forces, so you have a situation you're in, and you have this future situation you might be in. And the question is, are you going to make progress in that, from the situation into the other one? So there's a force pushing you from the situation. Like the situation you're in is pushing you towards the new, and the new thing might be pulling you because of the benefits that it has. So there's a cost of staying and there's a benefit of paying. Those are the pay forces. And then the stay forces, there's good things about your current situation. And so that was pulling you back towards staying. And then there are costs to pay to the new situation that's pushing you back from paying. So those are the stay forces. And what I'm trying to get you to do is I break down each of those forces into 2 dimensions, and then a simple, just combining them, you come up with a net pay versus stay. I don't think that you should use it like a formula, but just to give you an indication that there is more things indicating you should do something about it versus just keeping it, or more things saying you should just not worry about it and concentrate your effort somewhere else. Because it's not just the cost and benefit of any one thing. It's there's opportunity cost to picking which one you're going to do something about. So you want to try to do that with the one that has the best overall cost benefit.
That makes sense. I liked that example that you gave earlier about a long build process for iOS, I think it was. And you could imagine the dashboard being, a bunch of just dollar signs increasing based on, the time that developers are sitting around wondering what to do, right? And you can multiply out salaries. And
right. To be fair, the first thing they did was send us new machines, which did help. So,
sure.
Right. And but there was only so much you could do with hardware, and so we could see that it was still worth doing more. But that definitely did help.
Yeah, but I imagine most aspects of technical debt are not quite that easy to quantify, right?
Correct.
And so, I think
yeah,
having a rubric to kind of compare things, through pay versus stay forces, I think is really interesting. And I assume you do that on a team level.
Yes, team level. So yes, and I'm imagining that the way we did it was the iOS team did it amongst ourselves, and even though the Android and iOS teams were, somewhat a super team of 2 teams with common management, we did them separately because the code base. I think you do it based on your code base, the shared code base that you're working in, because you could all. Because the way I define tech debt is something that's in the code base that's only visible to developers working on it. Anyone else's opinion doesn't kind of matter. So about it. So so use whatever you commonly know about.
If they don't have access to the Git repo, then they don't get to talk about technical debt, right?
They
so
probably
product
don't.
owners, for example, are not going to be in those meetings, things like that.
If you need facilitation and your product owner might be a good facilitator, that's fine. Probably engineering manager could do it. Maybe you have program management, whatever way you want to do it. Third party, that's fine. Facilitation, the facilitator is the only person who is not participating. They're participating in facilitation. They're not participating in scoring and in opinions and so forth. Yeah.
Do you have a particular like cadence or anything that you recommend people meet about this? Is like if they're following sprints, for example, is it part of the regular sprint planning process? Or
if you have, I wouldn't say it's every. I mean, I'm imagining sprints that are in the couple of weeks long. So that's too that cadence is too quick. Different people do different things. If you're at a place that does safe and you have something like your epics, and maybe that's that's a better choice. Generally quarterly. I think you're going to need to kick it if you're not doing anything, and if tech debt is a problem. So if you're in a situation where you're just not doing anything, and it's a huge problem that you're not doing anything, I think you're going to start off with a couple of meetings just to kind of get it going, to get this idea going, and then I think quarterly is probably fine. Epic size is probably fine. If you need more because you have more turnover in that backlog and you just need more work to feed into it, then you might need to do it more often. I doubt you need to do it every sprint, but definitely could be some teams that have that.
Sure.
I doubt you would want to do it more slower than quarterly. It's like unless it's something like a huge 2-year project to do some kind of rewrite, which could happen. I'm not saying I don't recommend it, but I have done it in my career, and it's had to happen. If that's where you are, then it might be totally different. You might not be worrying about the rest of your tech debt because you have one single thing you're doing, and you just need to manage that one.
That makes sense. Would you consider something like a code library update to be technical debt?
Okay.
And something like that, I think of as, generally speaking, it's low visibility usually to
Yep.
users, and low impact until you reach that,
Right.
dreaded point where it's completely deprecated and now it's suddenly high impact, right? So how do you measure value on that?
Exactly. Okay, so I'm going to talk about it first, and then measure value second. So if you don't currently have some kind of dependency management plan, then for sure I would characterize your situation as probably a tech debt situation,
or a process debt there.
Yes, something is wrong. Whatever we're going to do about it, whatever situation you're in, it certainly would be in the engineering led bucket, I think, because it's not something. I think it's the kind of thing, it's how the sausage is made kind of thing, like where the rest of the company shouldn't be thinking about that. So to get from I don't even have a process at all to I have a good process, is going to be a tech debt thing that would be characterized in these ways. You're right. It would be hopefully you would start by putting it in your guide, your style guide. Now you would have misalignment to the style guide as your guiding benefit. You don't have visibility probably unless you have open security issues. You might have some, like you might have known security issues. Those might be there. And you're going to do something to come into some kind of alignment with a agreed upon system. This is what happened to us. This is the situation we were in on the iOS team, and then we adopted a 3-week cadence to updating all dependencies. Now that I'm doing that, that's just regular work. That's not tech debt. That's just me doing the spot updates, usually minor or bug fix updates that are coming in every 3 weeks. Usually one library or two. I wouldn't think of that as tech debt, but I don't know that once you're doing this budget that you need to worry about it too much. It's in the engineering led bucket. It comes from that time. It's going to be done with that resource. Whether it's tech debt or not doesn't really matter at that point, but you do have to deal with it. Value. How valuable is this? Really hard question. My main concern is just making sure there's positive value. So when I talk about the pay forces versus stay forces, I'm at least trying to get you, whether it's positive or negative, and the order of magnitude it might be. But I'm not trying to put a dollar figure on it. The dollar figure, you can kind of estimate the cost dollar figure of not doing something. But if you wanted to try, I think you could do something with static analysis on your code base, maybe looking at your Git history. If people want to look up a video by Adam Tornhill, there's a really good, he has a product that he sells that can do that and give you a visualization and direct tech debt resources. This is based on code reasons. So the complexity of the code or how hard it is to change, also trying to take into account how often it does change, can give you an idea of the cost of not paying it. It's not the only way tech debt causes costs. So but it is a way, and you might want to look at that. Then there's a cost of paying it. That's just normal project estimation. You should do that as part of this planning. It's whatever you think your estimate and plus risks are, and your normal way of sizing things is going to be. Now, on the benefit side, super hard. I think most of the benefits, developer productivity. I think it's a mistake to try to count developer productivity for too long of a time period, because then you can make an argument that you have infinite benefit, right? Over a long enough time period, I can get any benefit I want. So so I definitely would think about it in immediate 1 quarter, 2 quarters the most. Whatever your cadence, if you're doing something with your product roadmap, something like now, next, that time period, next time period, how much developer productivity you're going to get, and try to estimate it that way, using your budgeted, your salary as the way of turning it into dollar figures. But I don't think you need to do this if you're generally doing the biggest positive value things.
That makes sense. Yeah, and I like, if you're thinking about it within that engineering-led time, then you don't have to worry too much, I would assume, about putting value on everything, and like a minor library upgrade, for example, right? You're not. It's just part of normal operations, as you said, and so yeah. So overestimating that or putting too much of a value exercise on it is a little bit of unnecessary time, perhaps, right? So that makes sense. So you mentioned things like style guides, and as we're wrapping up here, I'd like to hear your thoughts on a little bit about how coding tools can help with technical debt.
So what I do now, I'm an advisor. I advise companies, product engineering, leadership on this kind of thing, but also other things. But I'm also working on a startup, so I am coding almost every day, and I use Visual Studio Code, and there are a couple of things I have installed that are about helping me not get into tech debt situations. So I use, so one of the things I try to do is give me an assessment of how, I'm going to just say how bad you think this code is that I'm while I'm looking at it. So in my editor, I have two plugins. One is just showing me the code coverage of my unit tests. So it'll just in the gutter, it's called coverage gutters or something like that. In the left gutter, it'll basically show me a visualization of my coverage. Xcode can do this. A lot of editors can do this, and I really recommend that you have some sense what your code coverage is doing for you while you're looking at the code and you're about to change it. Do you know that you have tests that are kind of helping you? But testing alone that's not going to, I think it needs to be combined with how complex the code is. So I have another plugin that also gives me like a complexity metric. So this is essentially how many paths are there through the function by analyzing the branches. So an if statement counts as one, a loop counts as one, a switch statement counts as each case, and so forth. And it kind of gives me a number on how complex is this code. So if code is both complex and not covered, then I have a rule in my style guide that says you can't make a change to that function until you first improve the coverage or break up the function. So that means that I will end up with, over time, simpler functions that are well tested. Not all of my code is like that, but it's a force kind of taking me there. And I'm seeing it while I'm coding. It's right in front of me. I'm about to change it. I can quickly refactor or quickly write a test, get some more coverage, and now I can do it. Another thing I do is there's this tool called diff cover. Essentially what it does is again, you have your coverage data. It can tell you the code coverage of the code in your PR. So the code you change in your PR. And then you can have quite a higher standard for that. So you might have code, you might not have good coverage right now. Maybe you have 50% coverage, 30% coverage, 0% coverage, whatever it is. And so you might not be able to get to 85% coverage, but you can probably get to some high number on just the PR diff, just the diff. So that could be a way of getting there. And so I use both of those tools. All three of those tools in my daily practice, and then other things like linters, formatters, all those kinds of things. They help.
Excellent. No, that's really helpful. I appreciate it. And so I just have one final question. I mean, we've gone this far in our discussion without mentioning the term AI. And that seems like a cardinal sin in technology these days. Do you think that a coding assistant like that, is it positive or negative for technical debt? I mean, or I guess, how should you use a coding assistant so that you are not accidentally creating technical debt with it?
Right.
Given that it's not going to understand the whole scope of what you're doing, perhaps.
Correct. Yeah. So I would just say I use a coding assistant for pretty much all of the time. And for doing, when I'm in charge of what's going on, which is almost all the time, it is helping me do that. So it helps me write tests. It can write boilerplate tests really, really well, and test data. It's really good at generating it. And so definitely think you should think about that. It's not, for me, I haven't found it's great at refactoring on its own, but assisting me doing it, it's pretty good. I know that people are having more success with that, and so I would try it. The refactoring tools generally, I think, have not really lived up to their promise, but refactoring is not something I consider to be that hard or that much of a drag on my time. I'm talking about simple, like a thing like extracting some amount of code into a method or something simple like that, not giant refactorings. But someone asked me recently, and it was kind of an interesting thing, and it was about AI. It was like, isn't AI, it's getting better and better at such a faster pace that maybe trying to do any tech debt paying now isn't worth it, because if I just wait 6 months or just wait a year, like there might just be a tool that just pays it all, like, or just does really great job. And like I might spend whatever 3 developer months or whatever doing it now, but later I'll be like, next year, if I just wait a year, I'll be able to do it instantaneously. And I can't say that that's not going to happen. Like I don't know that. I do think that there is one of the things I talk about in the book, and it's a really important part, that is that there's a developer happiness part also to tech debt. Paying tech debt helps with productivity, and it's doing that by extending your flow, by letting there be shorter feedback loops, by lowering your cognitive load. It's just making you faster. Those things also make you happier. Like if you look into the research on happiness, flow time makes people happy. Not having high cognitive load makes people happy. In my whole scoring mechanism, I also have a joy metric. How much joy would I have to just pay this piece of tech debt? And it's something you should consider. And I think the big reason to not ignore tech debt, even if you think AI is going to pay it off next year, it's like in the meantime, there's quite a lot of frustration happening on your team, and it's not. I think that alone trumps the whatever gain you might get. But to some degree, I understand that it's not totally wrong. So
that makes sense. Squashing tech debt sparks joy. Right.
Yes.
So maybe that's a good area for us to come to a conclusion on. But are there any other closing thoughts that you want to share with our listeners, Lou? And how can they learn more about your book and get in touch with you?
I have a website, loufranco.com, loufranco.com. I write a lot about tech debt. I'm going to, if you look in the blog posts, there's a category on tech debt. You can also sign up for an email subscription where I'll keep you updated on the book as it's being written. It's going to come out hopefully by the end of March. That's what I'm scheduled to do. But you can sign up to be one of the first people to know. And if you do, I'm intending that I'm going to send out a very highly discounted a code for a very high discount to everybody on the email list. So if you want to sign up just for that, that would be a good reason to sign up. But you can also read, I've been blogging for 20 something years. There's a lot of things there on tech debt, software development, generally software job hunting. And so you might find things on there that are of interest to you.
Perfect. So that's loufranco.com, and I'm on that email list already. And based on, the preview chapters that you've shared with people on that list, I can definitely say this is going to be a really excellent book, and I look forward to picking up a copy myself. So Lou Franco, thank you so much for sharing your expertise on tech debt with us today on the Scaling Tech Podcast.
Well, thank you. It's been a pleasure.
All right. Thanks to everyone for listening.
On behalf of the thousands of developers we've placed with our clients, I want to briefly tell you about our sponsor, Agility Feed. Agility Feed has been building nearshore agile teams for U.S. companies since 2010. We were an early pioneer in doing this sort of developer staffing. Our team can help you recruit talented software engineers and technical teams in Latin America. We'll handle all aspects of recruiting, contracting, and payments for you so you can focus on delivering great software. To learn more, check us out at agilityfeed.com. That's agilityfeat.com.